Okay, so this is part 3 of our series of talking about beginning Ruby, and it's not a tutorial of how Ruby works and not a tutorial of programming, but more or less pointing out some of the major stumbling blocks or edge cases that people tend to gloss over when they first start to learn Ruby or any programming language. And what we've seen here at Launch School is that as people move forward and don't take time to develop clarity on these topics, they tend to pay for it later as they try to learn more advanced knowledge. They're constantly being held back by lack of clarity on these concepts. So we're going to try to focus on some of these things. We've already talked about a lot of, I think, interesting aspects of the Ruby language. And I got a good question here from a participant here on this webinar. And the question is, if everything is an object, what is a variable, right? Because we're talking about variables as pointers last time. Variables as pointers to objects. And the problem that we're dealing with as we try to teach, not just Ruby, but teach programming to beginners, is that we have to selectively expose subsets of the language to you over time. And along the way, we have to help you establish a consistent mental model of how the language works without talking about more advanced things, right? So right now, we don't want to talk about, for example, the Ruby object model, which comes with the baggage of metaprogramming, right? We don't want to talk about those things because more advanced, and they'll come later in our program. So as you learn more about the programming language, your knowledge and your mental model of how Ruby works needs to be updated, right? So we'll have certain rules for you to follow each step of the way. And as you go forward, you'll see that these rules are actually not real rules, right? They're not real rules of the language. They're rules that we ask you to know each step of the way. One good example is when we talked about last time. We talked about the fact that how do you know if a method is going to mutate an argument? And part of the rule we ask people to memorize is that if the operation inside a method invokes a destructive call, that's how you know. But we saw last time that if you have a reassignment that happens beforehand, then that rule no longer applies. Or rather, it's not as simple as memorizing that rule, right? You have to update. Now you have to know if there's a reassignment that happens, then before that destructive call, then that destructive action is being invoked on a new method, unrelated to the argument you passed into the method. Understanding variables as pointers sort of helps close the loop here and provides a consistent worldview. So the question is, again, if everything is an object, what is a variable? For now, think of variables as pointers to objects, as something separate for now. Okay, just think of variables as pointing to an object. It is always pointing to an object. You could think of it that way. So that is the mental model that you should have at this point, and it will help you get through the trickier parts of the language and trickier code that you'll see. Okay, I got another question here. My thinking is that creating a variable creates a new object, but previous websites can point to an. So it's not always true that initializing a variable creates a new object, because a variable can be initialized to an existing object. Half the battle is trying to figure out whether or not you're pointing to an existing object or a new object. Here, A is pointing to a new object, B is pointing to an existing object. So we got two variables pointing to one object. Here, A is being initialized, it is being reassigned to a new object. Right? This is a new object because the plus operator, or fake method, remember from last webinar, returns a new object, new string object. Therefore, A is being reassigned to a new object. So it's not always immediately obvious that there's a new object in play, but there is in this case on line 4. Right, so for now, the question is, should we count variables as objects? And this is all terminology, right? We're getting into sort of the semantics of what these words mean, right? What does it mean when we say a variable is an object or a variable points to an object? The mental model of this code, for example, is that you have two variables pointing to two objects. That mental model will serve you well for now. And objects obviously have value, right? So changing the value of the object, all the variables pointing to that object will see the value, the change of the value. Yeah, so everything in Ruby is an object. That's very confusing. And so I would just ask you to hold on to that thought. Variables pointing to objects is a very sort of basic mental model. And part of the reason why people say everything is in Ruby is an object is that classes are objects too. But that requires a more deeper understanding of the Ruby object model, which we don't want to talk about yet. Right? So hang on to that thought. And another reason why developers say everything in Ruby is an object is not really about variables. It's really about, let's say, like integers. Because in some languages, integers and strings are what they call primitive types. And so they're not necessarily objects. So you can't invoke methods. We can't invoke methods on objects. And so this is why people say everything in Ruby is an object. And if you don't know another language, then there's no contrast. Then, it doesn't really matter, right? So we can say 1 times, or 1 times isn't, right? We can write code like this in Ruby. This is why people say everything is an object in Ruby, in that we can invoke a method on 4. A lot of languages we cannot. Right? We can say hi dot capitalize. This is invoking a method on string. In a lot of languages we cannot. This is why in Ruby we say everything's an object. It's not really related to variables. But I can see how it's confusing if you're trying to think about everything being an object. How do we think about variables? Usually when they say that, they mean there's no such thing as primitive types in Ruby. Oh, you guys can't see the screen, huh? That's no good. I've been typing for a while. Okay, I have some more questions here. Wow, we can't get to the main part of this talk. It's good though. Keep the questions coming because I do want to address some of these. So just to make sure I understand destructive method, reverse versus reverse bang. Right, reverse is not destructive, reverse bang is. That's correct. I wouldn't say that it replaces the original variable. It is a destructive action being called on the object. It changes the value of the object. And so all the variables that are pointing to the object see that change. When variables point to objects, they can either retrieve the value or they can update the value. Right? So I wouldn't say the variable is replaced. I would say the value of the object changed. Okay, great. All right, half the questions were really about why they can't see my screen, so sorry about that. Okay, cool. Any other questions? So thank you for the questions. So this mental model of variables as pointers to objects is going to come up over and over, and I think it's a good mental model to establish. And I'll switch back to my terminal because you guys couldn't see as I was typing. But in languages like Java, for example, you can't write this code. You can't say 4 times. You can't say the string hi capitalize. In Ruby, we can do that. We can invoke methods on these objects. We don't have primitive types in Ruby. And that's what people mean when they say everything is an object in Ruby, for the most part. Even classes are objects, right? Not really referring to variables. Okay, any other questions for now? Okay, we're good. Let me switch to the topic that we're going to talk about today, which is about collection. Collections, when we talk about collections in Ruby, mostly we're talking about arrays and hashes. There's obviously a lot of different ones too, strings as well. 3 major types of collections. So the first part is, what's a data structure or a collection? Data structure is a pretty generic term, meaning a structure that holds data. right? So a collection is, in my mind at least, a subset or a type of data structure that really refers to either arrays or hashes or strings, right? Some sort of collection oriented, like you can have multiple items in it. For example, an array, we can use this type of syntax in Ruby to create an array. Hash, we can use these curly braces, right? Array, you use the square brackets, and hash, you use the curly braces. And this hash rocket type of symbol delineates the key from the value. And so in a hash, we would have multiple key value pairs. In an array, we only have a series of elements. Another way to think about array is that it is a series of elements and it is retrievable. These elements are retrievable by its index. And so there's an implicit index that you can't really see when you look at an array, but it starts from 0 and counts upwards. So if you wanted to retrieve, for example, the third element out of this array, you would refer to index 2. So 0, 1, 2. That's the third element out of the array. The hash, on the other hand, are key value pairs, and we can think of this as a dictionary. So the keys must be unique in a hash. You cannot have a key value pair, multiple key value pairs with the same key. You can only have one key in a hash of the same value, that is. In an array, you can have as many repeats as you want to because we retrieve them based off of the index. So in hashes, most of the time, we create the hash like this, a:1. And the a: here is a symbol. So this is line 6 here. The example on line 6 is equivalent to this a:1. Just remember that a is a symbol. And in Ruby, we can have the key. The key can be anything. It can be any object. It can be a number. It can be a string. Usually, though, we want to try to use a symbol. This is a good question. Is an array ordered and hash unordered? I would say in most programming languages, you can think of it like that. In Ruby, I forget when they changed this, but I think it's in 1.9, hash order is preserved. But in general, you don't want to assume an order in a hash. You just want to retrieve a value by its key. But in an array, order matters because it's based upon the index, right? It's always 0, 1, 2, 3, and so on. It won't be a mixed up sort of index. So major differences between array hash, order, although like I said in Ruby, the hash insertion order is preserved. That happens to be the case in Ruby. Index retrieval versus key retrieval. And arrays can have duplicates, but hash keys are unique. So those are the major differences. A lot of times early on in your programming journey, as you learn a program, it's pretty confusing when to use a hash versus an array. As you code more, you'll start to develop an intuition, and switching between them will become easier. In the beginning, it's going to be very painful. Right, so you'll go down trying to solve a problem using a hash where it's better to use an array, and you'll be writing a very convoluted code just to handle the fact that you chose a hash. Sometimes it's easier to back out and choose an array, and you'll see that this problem just lends itself more naturally to a different data structure. And that will happen over and over. So if you find yourself doing that, don't be too frustrated. That's just sort of how you learn. Just to clarify, A in hash is the key. In this example here, we would say that this is the A symbol. So in Ruby, there are two sort of different types of things that seem like they're strings. One is a string, one is a symbol. The difference being that symbols are immutable. You cannot change the value of a symbol. So A here is a symbol. Give an example. So let's say I have a hash like this. Notice that I initialized this hash using this type of syntax, but I can see the return value is a symbol A as the key with the integer 1 as the value. As long as you understand that this is a symbol A, that's fine. It's not the string A. So in other words, if I wanted to retrieve 1 out of this hash, confusingly enough, I use the bracket syntax. It almost looks like array retrieval. So I'll get nil here. And another kind of scary part about this is that you notice it didn't throw an exception, right? It just sort of silently returns a nil. What if the value itself is nil? How do I differentiate between the fact that this key value pair doesn't or this key doesn't exist versus the value itself is nil? You can use the fetch method in that case. That would be a little bit easier. And you can see that it'll throw a key error. So a lot of people, for this reason, a lot of people will prefer fetch over the brackets retrieval syntax. But either way works. And if I retrieve it using the symbol, you can see I get my 1 value back. Right? So very important. These little things will, if you haven't been burned by this at least a dozen times, it's okay. Don't worry. It'll come. Just when it comes, don't get too frustrated and don't be too hard on yourself. Everybody learning Ruby has, or any programming language, will run into this a lot. No, symbols are not constants. Constants is a different type of variable. So Ruby also has constants. Think of symbols as immutable strings. And that's it for now. Which is better practice? You mean like when you initialize a hash, whether you want to do this versus this? I don't know that there's a better. They're the same thing. I prefer this because it's less typing. But they're the same. There's no better there. Okay, I'm going to just quickly do some exercises and then we'll talk about sort of common methods and mistakes that people make. Just to get our feet wet with these things, and you'll also, I'm sure this will, as we do this, will generate some questions. So I can either do this in IRB or do this in an editor. One thing I like about the IRB method is using IRB is that you can see the return value, which is often suppressed when you run the code, right? Because you don't care about the return value. So if I were to initialize the array A here to an array between 1 and 10, I want to print out each value in the loop. I want to print each value in the array, and I can use loop or iteration, right? I'm going to type out an editor just so I have more things to work with, but I'll run it in IRB as well, just to give you a comparison. All right, so think about this. I want to write a loop that loops through this array. So how do I do that? How do I retrieve a value out of this array? Let me do ARR just a little bit better. I would do, right? That's the index. 0 is the index. So 4 is the third element. 1, 2, 3, 4. Or the third element. 0, 1, 2, 3, 4. I'm sorry, 0 is the fifth element. I went the wrong way there. Right, so that should give me 5. Right? I need some way to loop through this array and continuously retrieve the element out of this array based upon its index, starting at 0. Right? Now I got an infinite loop here. Obviously I need to increment this variable. And I need to stop. IDX. Right? This is one way I can iterate. Okay, hopefully that wasn't too surprising for anybody. In Ruby, we have these things called iterators. So instead of writing this looping construct over and over for arrays, we have this method called each. Each takes a block. What are blocks? Don't worry about that. Just memorize it for now. Again, the mental model of what blocks are will come. It requires a little bit more knowledge, I suppose, at this point. But the way you should think about this is that the block is being passed into the each method. It's an argument. And blocks, again, if you come from a different language, blocks you can think of as anonymous functions. Like in Java, we have anonymous functions, right? In Ruby, we have blocks. It is one way that we can pass sort of chunks of code around in Ruby. This is a very powerful programming technique, right, called closures. Again, all that is maybe too much information right now. Just know that blocks are chunks of code that we can pass into a method, and that method will do something with it. What will each do with it? What will each do with the block? Each will just execute the block for every element in the array. That's it. And each will give you what's called a block argument, and you can then do whatever you want it is to each element in this array. And I'll comment out my loop. Right? Same thing. Subtle difference though. Kind of a subtle difference. Do you guys know the difference between these, the looping and the each? I'll copy it into, copy and paste it into IRB. Okay, I need my ARR. Okay, so look at this. Output and return value versus this. Notice the difference? So anybody know the difference between these two looping mechanisms? One is using the loop keyword, and we wrote some code to sort of keep track of the index. And then the other one we use each. It's the return value, right? Notice here we return nil. Here, this is each. It returns the original array. It's the return value. If we just run the code in our editor, we won't notice the difference at all. Kind of subtle. Not too important in this case, but there will be cases where that's important. So in Ruby, we always have to be aware of the return value of our code, no matter what, right? Just because sometimes by accidentally modifying the return value, especially if this is in a method, right? Let's say we're writing a method and either implementation works. Well, if your method depends on the return value, then you better make sure you're choosing the right way. If your method doesn't care about a return value, then maybe that's okay. All right, great. So loop versus iteration. So same as above, except instead of printing out every number, we only want to print it out if it's greater than 5. All right, that's pretty easy. I'm going to comment out the manual loop here, but it's the same thing. I can just be, I can add a condition. If n is greater than 5, right? Pretty easy. I can also put at the end here because it's only a one-liner in my if condition. Right? That's what Ruby allows us to do. Okay, and then append 12 to the end of the array. If you guys want to try some of these ahead of me, go ahead and do so. No problems. Append 12 to the end of the array. So no more iterating. Right? Got 12 there. Next one is prepend. Let me switch to a different view here. Let's move that over there. So prepend 0 to the beginning. I believe unshift will do this. Right, got 0 in the beginning now. Remove the 12 and add a 3. Pop will remove the 12. Yeah, somebody said upshift. That will work too. Push and pop push will work. There's like multiple methods that would work here. So I'm glad that you guys know that. So remove the 12 and add a 3. Okay, so I remove the 12, add a 3. This is confusing. Okay, so we're here now. Okay, we want to remove duplicates using one method, i.e. don't iterate. Okay, so there's a method called unique. Without the U and the E, we get to save 2 characters, right? Okay, so this is a problem. So notice I did unique here and I print out the array and nothing changed. And part of the reason is because it's not a destructive call, right? So again, I'll hop in IRB and I'll do ARR is this. If I say ARR.unique, it's going to return a new array that removes the redundant values. I have 2 3s, so the second 3 is removed. But if I look at ARR, it didn't change. If I want it to be a destructive method, I just add a bang there. Now, this is not because I get to add a bang to any method that I want to. It's that there are 2 different methods that exist. One is called unique, one is called unique bang. There's 2 different methods, and they're implemented differently. So if I want to see this in ARR, I have to add a bang. Oh, whoops. Okay, this might be too basic. Hopefully you guys all know this. We'll get to the more fun stuff pretty soon. All right, extract all odd numbers into a new array. So this is about selection, right? So I'm going to blow this away. Select. And again, the way we read this is that there's a method called select. This block is being passed into the select method. And what does select do? What does select do? Select returns a new array that meets the criteria specified in the block. I'll tell you why. So that is a okay definition, but I'll tell you why that definition that I just said is insufficient when you are challenged to really understand what's happening. I'll come back to it in a bit. But what I just said is select returns a new array depending on the criteria specified in the block. P odds. Right? It's got all the odd. Now, why is that an imprecise definition? So let's take a look at this for a second. If I were to ask you to write the definition of select, criteria so a lot of times, especially in the first assessment, we ask you guys to be very precise in your definition of certain methods like select and map, especially. And the reason why we ask you to be so precise in your memorization almost of these methods is because when there's simple code like this, pretty easy. It's not taxing sort of the edge cases of your knowledge. But let me change up this code up just a tiny bit and you'll see how that definition sort of falls down. And it's really hard for you to decipher the code based upon that knowledge. So suppose I want to add some, let's see if I did this. What do you suppose line 21 is going to print out in this particular case? Select returns a new array that meets the criteria specified. Well, okay, the criteria specified in the block now is not whether it's odd, it's that it's n plus 1. Think about that for 1 minute and see if you can take a guess at the answer. Okay, I got a good one here. It evaluates to true, so all values are selected. That's right. That's true. So the problem is our definition didn't help us, right? So let's update a little bit. This is take number 2. Okay? So what if I did this? I put in, because I want to see the output of this and debug a little bit. What is line 24 going to output in this case? What is odds, basically? So looking at our definition here, can that definition help us? Okay, I got a couple guesses. Somebody said evens. It's not going to print out evens. Nil. Nil is not right, but it's almost right. An array of nils. That's exactly right. And odds is going to be an array of nils. I'm sorry. Even I got confused. This is why it's tricky. It's an empty array. It's an empty array. Because nil evaluates to false. So the definition that I think we should focus on is so select returns a new array based on the block's return value. If that return value, so it is referring to the return value, evaluates to true. Not that it is true, but evaluates to true. In other words, we're looking at the truthiness or falsiness of the return value, right? I'm going to put this in asterisk, right? The return value. If the return is true, then the element is selected. Otherwise, it's not. In this case, puts in returns nil. It's because it's the last line of this block. This entire block evaluates to nil, which, this entire block returns nil, which is falsy. Right? It's not false, it's falsy. Therefore, no element is selected. Right? See how we iterated on these definitions. Having this stored in your head is going to help you so much more when you're trying to evaluate sort of more complicated code. And it's important to have the right definition. All right, we'll do one with map next. Okay, so I want you to memorize this. Select returns a new array based on the block's return value. If the return value of the block, right? Return value of the block. If the return value of the block evaluates to true, then the element is selected. If the return value of the block is evaluates to false, then the element is not selected. That's really it. So the return values of the block is what's really important, and select cares about the return value's truthiness. Not whether it is true or false, but truthiness. Okay, so I'll just comment this out. All right, let's continue here. So the next question is increment all numbers by 1. Okay, my array is still there. Okay, increment all numbers by 1. So this is a transformation, right? This is a transformation for every single element. Pretty common method that does this is map. We can definitely use a loop, but we can use map. Right, we'll look at the incremented array here. And you can see that we have an array where every single element is incremented. So if I were to ask you to provide a definition of map, You might say something like this: map returns a new array based on the transformation specified in the block, right? You might say something like that. That would be fine, but a little bit imprecise. Because if I said n greater than 1 here, what is going to be the transformation of incremented? It's going to be an array of booleans, because this is a transformation. It's not going to be only the elements that are greater than 1, right? Or if I did n dot odd question mark, right? It's not going to give me only the odd elements, because map is transformation. It's not selection. Just like selection is not transformation, right? Even I got confused there for 1 second, where all the elements would be nil. That's not how select works, right? Select doesn't transform. Select cannot transform. Select can only select and filter. Map, on the other hand, cannot filter. Map can only return array.size with array.size elements in it, right? So it's going to return an array of booleans. And so this, and then if I say puts in down here, what is incremented? Yeah, finally we get an array of nils in this case, because puts returns nil, right? Puts returns nil. So just like updating our previous definition of select for map, we have to have a very precise definition. Otherwise, this particular definition doesn't help us as much. Specified in the block. What does specified mean, right? Remember that when we are memorizing definitions or memorizing how things work, we have to focus on a few keywords here. One is the return value. Two is side effects, right? Return value and side effects. Those are the things that we need to speak about, not results, right? When we say the result of executing that method is 5, that's not necessarily wrong, but just very imprecise, to the point where we don't know what you mean. Do you mean the return value of that method is 5? Or do you mean that it mutated an argument to 5? Or do you mean that it outputted 5, right? Those are the three things: return, side effect, or output. Not results, not specified. It's very important to use those three words in particular. So map returns a new array based on the blocks, just like select, return value. Right, return value. Each element is transformed based on the return value. Right, so notice that block and select pretty much work the same way, in that it looks at the block's return value, but select looks at its truthiness value to make a selection judgment, whereas map just performs the transformation. In fact, I can just say it has nothing to do with this block argument that we pass into the block. It can just be unrelated to that element. In this case, incremented will be an array of strings. So it doesn't even have to manipulate this particular element, incrementing by 1 or whatnot. Okay, and hashes work in a similar way. I'll skip this exercise. I think we did last time anyway, so just in the interest of time. Any questions about this? So the point here is to show that even simple, very, very simple methods like select and map have some depth to them. And it's very important to have a very precise definition in your head of how they work. If you don't, you may be able to get away with it for now, and you won't really run into any problems until you run into code that violates this definition, and you won't know how to recover. Again, it's about sort of constructing that mental model of how it works for the time being. Okay, let's work with hashes for a little bit. But the concept of array of map and select are very similar in hashes. So I'll try to go a little bit faster, because I do want to get down here and talk about enumerable for a second. So if I have a hash like this, How do I get the value of B? Oops. This is kind of a trick question because you can't get the value of B. Right? Because B is a symbol. You have to retrieve it this way. Okay, add this key value pair to the hash. So the way we add, I can just do this. It's sort of like the retrieval syntax, except we set it. And if we look at hash now, we have E5 in there. Iterate over the hash and print out the keys and values. So hash, just like array, has the each iterator. I'm going to go back to my editor now. I have E5, right? And one small difference is that the argument to the block now has 2 arguments. The block has 2 arguments. The first represents the key. The second represents the value. So I can just say key is key, value is V. Right, and I can write a manual loop just like before. I don't have to use the each. Print out the key value pairs where the value is less than 3.5. If V is less than 3.5, return a new hash where the value is less than 3.5. Return a new, so I can use, instead of select, I can say reject, right? Or I can use select too, I suppose. So I'll use select here. Select key value pair. And return a new hash where the value is less than 3. So this will be a new hash. Small vowels, piece, small vowels. Right, this is going to be a new hash. My original hash is unmodified. And delete all the key value pairs where the value is less than 3.5. So here I can do delete if, I suppose. Delete if V is less than 3.5. Right? So I won't change the variable name, but yeah, my hash is deleted. Or my hash is modified. Right? So delete if is a destructive call. And so these are other questions to think about. I guess I won't get into it too much. Can an array contain hashes and vice versa? Yes, definitely. Modify an array inside of a hash. So one thing you have to be aware of when working with collections, and this people kind of make this mistake a lot too, is if you have, let's say, we have our array, right? Yeah. So let's say our ARR, we're going to add a new hash in here. In fact, we'll do this. We'll append our crazy hash in there. So if we look at array at this point in time, the last element in this array is going to be this giant hash. Right? The last element gets a little bit hard to read, but this is an 11 element array where the last element is a giant hash. So if I were to change the hash here, say I add a new thing, a new key value pair. Well, that's going to work before, but oh yeah, this works. This works. So I added the hash into the array first. Then I modified this hash, right? And you can see that ARR is modified as well. Again, this concept of variables as pointers, right? And hash is pointing to an object. Hash is going into the array, but if I keep modifying this object, array will see it too, because now this object is part of the array, right? So that's a little dangerous in that you're not modifying ARR, and yet an element within ARR is changing. Right? This can get very, very confusing if you have an array of custom objects like people, and the people, let's say the names are changing underneath this array. So something to be very, very careful about. And vice versa, modifying an array within a hash. Same thing. If one of our values was a hash, we can modify that array without touching this hash. So you can have code where you're not touching a variable, a hash, right? And therefore you may think that nothing is changing. But if you have another variable pointing to an object that's within this data structure, this collection, then it still could be changing, right? Okay, I already talked about the transformation and selection mistakes beginners make. The main one was having an imprecise definition. That's the main one I see. And whenever sort of unfamiliar code, you run into unfamiliar code, if your definition is not precise, you sort of don't know what to do. So if you think that map is a transformation that can only be performed on each element, and you see this code, it's like, whoa, I didn't know that was possible. Having a more precise definition is going to help you read that type of code. So I would challenge you to sort of memorize it the way that's written here. Last thing I want to talk about is in array and hashes, we have a lot of different methods available to us. So for example, if I have I'll grab my ARR here. Right, we have something called all. And all you can ask it questions like, are all the elements here odd? It'll say false. Okay, are all the elements here less than 10? It'll say false. Well, let me change that to 11. Now it'll say true, right? You can also ask it any. Are any less than 11? Or less than 5, let's say. Are any less than 5? Yes, some are less than 5, right? If we look at the documentation for array, let's go to Ruby docs. Okay, I like the Google ads here. Very nice touch. Any. So any is here, but all is not here, right? You see that? I'm looking at array. All is not here. Where is all coming from? Seems very odd. So here's a small hint in that any, it tells you to go to enumerable. If we click on enumerable, now we're in this module called enumerable. And you can see we have any and all. This is a module that is mixed in to arrays and hashes. And it gives us a lot of very, very interesting and extremely useful methods. For example, we can determine, well, first, use all the time. At least I use it all the time. Max and min, I use all the time too. Right? Map, obviously we use all the time. Reject, select, sort, use all the time. 2A. So many incredibly useful methods are actually provided to us by Enumerable. Now, if you haven't gone to the OO side of things in our program, you probably are not too familiar with modules versus classes yet, which is okay for now. Just know that there's a lot of collection-oriented methods in this enumerable module. You know, why is it enumerable instead of arrays and hashes? Well, you could put it in two different places. Instead, they moved it to one. You say, well, aren't they implemented differently? Right? Aren't these, or any, all, they should be implemented in different ways for arrays and hashes, right? If you read the documentation here a little bit, it says the class must provide a method each. Okay, so think about what that means. Array has an each, hash has an each, and according to this documentation, that's all you need to use enumerable, to mix in enumerable. What this means is that all enumerable cares about is you tell me how you iterate. And I will use that iteration mechanism and give you all this functionality. So all this functionality are layered upon the iteration mechanism. So you can think about how do we implement any in a collection. As long as you tell me how to iterate through your collection, whatever it is, it can be custom objects, it can be integers, doesn't really matter. I will rely on that iteration mechanism and then pass in this condition and perform that test, that condition on every single successive element. And then stop as soon as I reach the first one, because any means any one, right? All is a little different. All is I will perform that condition, like if it's odd or whatever, less than 11. And if anyone doesn't, I'll return false, right? So the iteration mechanism is most important. This might be a little bit too much information, but the most important thing I'm trying to convey right now is if you were to look up documentation about one of these collection-oriented methods, you can find them. If you can't find it in the array or hash class, you can find it in Enumerable. And as you go through sort of your programming, learning to program iterations, array, hash, and enumerable are going to be extremely critical. You'll have to get familiar with a lot of methods in array, hashes, and enumerable. All right, that's the time. Any questions? Any follow-up questions? I do have a few minutes, so sorry it took a little bit longer this time, but so okay. Well, if no other questions, then we'll call it a day, and we'll do it again next weekend.